All right, today we're talking about the counting principle and permutations. Can I get somebody to read this paragraph right here on snowboards? Thanks, Eddie.
Snowboarding. A sporting goods store offers 3 types of snowboards, all mountain, freestyle, and carving, and 2 types of boots, soft and hybrid. How many choices does the store offer for snowboarding equipment?
Great, thank you. So, when you're doing this, you can always figure out how many choices you have for different things. So if you were to go into the store, you have the choice. You could get an all mountain board, and if you got this board, you could choose either a soft or hybrid boot. So for the all mountain, how many choices do you have? 2. With the freestyle, same thing. You could get soft or hybrid, so you have another 2 choices. And then with the carving, you have another 2 choices. And so how many total choices do you have here? 6. Now, you can do a tree diagram for all the problems when you're trying to figure out how many possible choices are, but there is a shortcut. And the shortcut is this. There are 3 types of snowboards to choose from. So you take the 3 and you multiply it by the 2 types of boots that there are, which is 2. And you multiply 3 times 2 together and you get 6. There are 6 total choices. Okay. So again, fundamental counting principle is that you multiply the number of choices for each decision, which will then give you your answer. Okay, so we're going to go ahead and go down to this sporting goods example. It says the store in example 1 also offers 3 different types of bicycles. So I usually will underline my important information. 3 different types of bicycles, which include mountain racing and BMX. And 3 different wheel sizes, which are 20, 22, and 24 inch. How many bicycle choices does the store offer? 9. So what would we do? We would go 3 times 3, which equals 9. Very good. Okay, now we always start off with something kind of simple to give you the idea, and then obviously we get into stuff that is more complicated. Okay, so license plates. The standard license plate configuration for a Texas license plate is 1 letter followed by 2 digits followed by 3 letters. Okay, so I'm going to write A right here because we're going to talk about A. So for this one, it says that there is, they said 1 letter, and I usually go 1 L. I just do a blank with an L because this is for letters. And then it says 2 digits. So for those, I do number. And then it said followed by 3 letters. So another 3 blanks. 1, 2, 3 blanks. And those they said were letters. So that's how the Texas license plate goes. Letter, number, number, letter, letter, letter. And they gave us that information here. We all agree with that?
Yeah.
Okay. So when we read A, it says how many different license plates are possible if letters and digits can repeat. So what they mean by that is that you could have A in all the letter spots, right? They can repeat letters. Sometimes they'll say letters can't repeat, and that's going to change things. So who knows how many letters are in the alphabet? 26 is correct. So for each of my letter choices, what am I going to put? 26. Very good. For my number choices, how many numbers, like single digit numbers, are there?
10.
10 is correct. Why is there 10? 0.
Do you have like a negative number? I want that. Be the first one to have negative.
Okay. So there are 10 numbers. We multiply all those together, and you probably want a calculator for this. I mean, I can do it in my head. I don't know about you guys. I'm just kidding. I can't do it in my head. I just already worked it out.
Oh, amazing.
So when we multiply that out, and if you don't have calculators, you might want to grab one. You're going to need one. But it's 45,697,600. And that is your answer for A.
I got 180.
How many combinations? Let's not worry about it right now.
But I mean, is that how
That's how many like different ways you could write the license plates if nothing repeated. Right.
Yeah.
It's That's not right. Yes, it is. Which would make sense. I mean, think about how many people live in the state of Texas. A lot. And so there's a lot of cars. So they need to make sure none of the license plates have the same license plate number. Okay. In fact, in California, there it used to be less on the license plates. If you look at the old license plates, there are less letters and numbers than there are now. I can't remember how many there are, but okay. So for B, read B and tell me what is different on B than there was on A. It says numbers and letters cannot be repeated. So what that means is basically you're going to use one letter and then you have one less letter to use. So let's just look at the letters. When I start with my first letter, how many letter choices do I have? 26. But I use one of those letters. So that means my next letter spot is going to be 25. And then, okay. And then with my numbers, how many do I have for my first choice? 10. And then I used one, so now I have 9. And so now you're going to multiply all those together.
I wish there was a fact-based one.
32,292,000 is the correct answer. That's right. So notice that if you can have repeats, there's like 13 million more choices, approximately, than if you can't repeat. That's a big jump.
Yeah.
So do you think you really need to pay attention to repeat and not repeat? Yes. Super important. Okay, so when you're dealing with permutations, and this is something you're going to want to remember, you need to know that order in permutations is very important. Okay? And we'll talk about this too more as this unit goes on. But can you guys give me some examples of things where order is important? Filing. Think about like a library and books. Order matters. What about chemistry? Mixing elements and stuff. What about like in a race? Does order matter in a race? Yeah, because the first person gets first, second is second, and so on. But like, let's say you're in a club. Does order matter there? No, it doesn't matter like who walked in first, second, or third. You guys are all in the same club. You're all there, right? Okay. Order of operations. Does order matter? Yes. Okay. So, there is a formula for permutations. This is the formula. I think it's much easier to teach you a shortcut than to teach you the formula. So it's there for you, but I feel like I know a better way. So we're going to learn the better way, if that's okay with everybody. The one thing that you do need to remember, though, is that M is talking about the amount of objects, where R is how many objects they take. So like M is how many are available, R is how many you're taking. For instance, on this back problem, the amount of objects in an alphabet is 26, but I only took 4 letters from the alphabet. Okay? So on this one, N is my letters, but R would have been 4 because I was only taking 4 letters from the alphabet. Okay? Something else that you need to know is that this right here means 6 factorial. Okay? 6 factorial means that you take whatever number they have there and it goes 6 times 5 times 4 times 3 times 2 times 1. Okay? So if I had, let's say, 3 factorial, what would that be?
3 times 6.
Exactly, which equals 6. Okay? All right. And there is a shortcut for this on your calculator, but I'm not going to show it to you yet. Okay. I will at the end of the lesson. Okay,
Off camera.
moving on to example 3. It says, how many 4-letter patterns can be formed using the letters A, B, C, and D if each letter is used exactly once? So, how many letters are we going to use? 4. And how many so we have 4 letters we're using, and are we using all 4 of them? Yes, because we're making a 4-letter pattern, and we have 4 letters we get to use. So my N and my R are the same in this one. Okay, so I'm going to make 4 blanks. 1, 2, 3, 4. And these blanks, we always end up multiplying them together. So my first blank, how many choices do I have? 4. But we're using 1, and we can only use it once, so that means in my next blank, how many do I have left? 3, and then, and we multiply that together, and we get... Some of these we can do without a calculator. All right. Okay. Example 4. It says, how many ways can 3 books be placed on a shelf if they are chosen from a selection of 8 different books? So how many blanks am I going to have? How many books are we choosing?
8. 3.
We're choosing 3. So I'm choosing 3. I'm going to make 3 blanks. How many books do I have to choose from? 8. So I have 8 in this first one. Now, do you think I can, once you choose a book once, could I choose that same book again? No. Okay, so it's going to be 8 times 7 times 6. And we multiply that together, and what do we get? 336 would be the correct answer. Okay. Questions so far? All right. Now, in this formula here, okay, you have your permutation. If you go back, I told you that N represents objects and R is how many you're taking, right? So in this, it's NPR. So there's a total of N objects. Take an R at a time. So this number right here is your number of objects. And then this is how many you're taking. So with that information, how many blanks are you going to want on number 4? Very good. You want 3 blanks because you're taking 3 of them. And what number goes in the first blank? 5 and then